All right, so today we are going to model the equivalence of tenths and hundredths using the area model right here and then some place value disks later on. We have done this before, so you're familiar with it. However, we just haven't done it with decimal type items. The way this works is that we're going to take grid and we're going to shade in one of these pieces right here. Okay, so now we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we've shaded in 1. So we had one whole piece right here. And we shaded in 1 out of 10 total pieces. Now, if we were to multiply this by 10, cut in half, and then in each half into fifths. So now I have a total of 100 pieces, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them are shaded in, but I didn't change my shaded region. So 1/10 equals 10 100ths. So what I've done is I took my 1/10 and I multiplied it by 10. And I came out with 10 100ths. Now if I had two pieces side by side, for this one, I'm going to shade in 1, 2, 3. So here I have a total of 3 shaded in pieces with an altogether total of 10. Now if I imagine this as just tenths, I'm going to shade in one whole row of 10, so 10. Another row of 10, which gives me a total of 20. And another row of 10, which gives me a total of 30. And an altogether total of 100. So we can also say that 3/10 equals 30 100ths. 3/10 as a decimal equals decimal point 3/10, and 30 100ths as a decimal equals decimal point 30. So I could say that 3/10 equals 30 100ths, or I could say that decimal point 3/10 equals decimal point 30 100ths. They're the same. And we modeled that through our area model. You can go the other way as well. When we did this, we multiplied them because we took a low number, like 10, and we made it huge. Well, this time we are going to do the opposite. We are going to start with our hundredths. I'm going to shade in, oops, did it again. I'm going to shade in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, one row, and another row. So here I have shaded in out of a total of 100, I shaded in 20 of them. Now, if I were to go to the tenths area model, to make my tenths, I shaded in 10, 20, which is 2 rows of 10, or 1, 2. So here I have 2 tenths, and you can see, looking at our area models here, you can see that they look identical, except for one is cut into 100 pieces, and the other is partitioned into 10. So what I've done here, what I've modeled here, is I took 20 100ths, and I divided that in 10. And I came with an answer of 2 tenths. So now we're going to do, if you're counting, you don't always have an even number like 10, 20, 30. Not everything's always a multiple of 10. So what I'm going to do is, on our thing like yesterday, I'm going to model 25 100ths. Now, just like we did yesterday, we have a total of 1. It's one whole piece. And it's partitioned into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we look at 25 100ths, if we used our knowledge of place value, we have 2 tenths right here, and we have 5 100ths. So let's start with our 2 tenths right here. Hello, why aren't you changing colors? We're going to start with our 2 tenths. 1, 2. So we got that one taken care of. Now we're going to go into our 5 100ths, which is, we are going to partition this next one, because 5 100ths is under one whole. Oops. I have to make tinier slivers. Let's try that again. We're going to partition this one into tenths. There. Now I'm going to shade in our 5 100ths. 1 100th, 2 100ths, 3 100ths, 4 100ths, and 5 100ths. So now I've modeled 25 100ths as a fraction on an area model. Now, going to show on a hundredths chart what that would look like as well. There. So in order to show 25 100ths, we made that number bond that showed that 25 100ths was 2 tenths and 5 100ths. I'm going to shade in one set of 10, 2 sets of 10, and then 5 individual units. 1, 2, 3, 4, and 5. So I have 10 100ths 2 times. So 10 100ths here and 10 100ths here. plus an additional 5/100ths. If we go into place value, so here I have two digits. I have 0, 1. And if we were to dissect this a little bit, we would know that 0, 1, decimal point 0, 1, if we were to make a number bond for this, thinking about decimal place value, we look right here and we find that we have 0 tenths, and look here, we have 1/100th. So knowing that, I want to get 1/10. How many 1/100ths do I need before I make 1/10? So this is where we think back to our honeycomb. How many of these right here do I need before I get 1/10 or 1/10? I need 10 of them. So we're going to do that bundling thing. We're looking for tenths. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or I could count in hundredths. I have 1/100th, 2/100ths, 3/100ths, 4/100ths, 5/100ths, 6/100ths, 7/100ths, 8/100ths, 9/100ths, and 10/100ths. So I have 10/100ths right there. I have 10/100ths. 10/100ths we found out was equivalent to 1/10. 1/10 written as a decimal is 0 ones and 1/10. And I have an additional 1/100th, 2/100ths, 3/100ths, 4/100ths, 5/100ths, 6/100ths. So I have an additional 0 ones, 0 tens. I did not get to bundle. And I have 6/100ths left. If I added these together, right here, I have a total of, I don't have a whole piece yet, and I have one group of 10 and 6 leftover 100ths. In order to make a number bond for that, I had 0 ones, I had one group of 10, and I had 600ths. So I had 1/10 and 6/100ths. So it is not too bad. I want to go back up to this one, slide number 5, and I am going to clone it. Clone! Ta-da! Okay, so what I have here is not only 25/100ths, but I have, if we look at this closely using our benchmark fractions, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in each column. 1, 2, 3, 4, 5. So another way of putting this is that using our benchmark fractions, I have 2 full tens and 1/2 tenths, because 5 is 1/2 of 10. This is another way to put it. All right. So finding the equivalent between multiples of 10 and their matching hundredths decimal, not all that bad. Something that we've done before. If you start out with your tenths, finding the equivalent fraction, not too bad.